Hello and welcome to the channel Understanding.Concepts.Of.Physics. We have been discussing graphical representation of linear simple harmonic motion for a particle which is beginning from the mean position. And in case if you have not watched the first part of this video, I would request you to go back and watch the first part where the half of the explanation lies over there. So I have explained you how displacement, velocity and acceleration equation gets and how this table has to be filled up. This has been explained in the part 1 of this video. This is the part 2. I would really request you to go back to part 1 and visit the playlist and see the video. Now today we are going to see how to represent this linear simple harmonic motion in graphically. And in order to represent that, I need for any graph actually we need equations, and with equations we can collect data, and with data we can plot a graph. So we have reached equation and data and we are supposed to plot the graph today. So this is my data. So this is your time, this is the phase, this is displacement, velocity and acceleration. Time starts like 0 and it goes like t, then half of t and half of this, that is t by 4, 3t by 4, 5t by 4. So if you remember, 0t by 4, 1t by 4, 2t by 4, 3t by 4, 4t by 4, 5t by 4. This is 1. And the phase will go like omega t, and omega is basically 2 pi by t. Omega is 2 pi by t, and in place of t we can put all the values. So like individually if we put t, so omega is 2 pi by t into t is 0, so everything goes to 0. So I have shown this how to calculate the entire thing. Right now today we are supposed to plot the displacement time graph, velocity time graph and acceleration time graph. So we know that when x is 0 the time is 0, when x is a time is t by 4, and so on and so forth. So I'll just plot that graph. I have this grid lines over here. I have plotted if you note that this is your x-axis, this is your displacement, this is your time axis, this is your displacement axis, and the center is 0. This is the origin. Now I am seeing that the displacement has a maximum value of plus a to the positive side and minus a to the negative side. So I can just write here as this is a and this is minus a, and my time axis has t starting from 0 to 5t by 4. So I'll do that part as well. So I have this white colored, and this is t, this is t by 2, that is half of t, and t by 2 ka half, that is t by 4, this is 3t by 4, this is 5t by 4. So this is your time axis. I'll also do this in white itself. So a minus a. Now one by one we'll keep on plotting the points. So I see that the displacement is 0 when time is 0. So 0 comma 0 is my first point. So my first point goes like this, 0 comma 0. This becomes my first point. Okay, so this is my first point. Now next is t by 4 to a. So time is t by 4 and the displacement is a. So the next point will be here. So I would get something like this. Okay, I hope you are able to see. I have just plotted that t by 4 comma a. Next point is t by 2 comma 0. So t by 2 comma 0 somewhere around here. Next point it would be 3t by 4 and minus a. So 3t by 4 and minus a. So this point will come here. So the next point is here, the next point is here. Then you can just move and just keep on doing it, and you will see all the points would look somewhat in this pattern. And now what we can do is we can join these points and it should be in a curve. So the point should go like what I am making you see this. Okay, so I'll just plot it and I'll make sure that it looks good. So this is next 0, and then you have this. So this curve would look like this. Oh, so this curve would look something like this. Okay, and then the below curve would look something like this, and then it goes like, okay, because not going on a curve. So this is that curve. So this is yellow curve is what is the displacement time graph for a linear simple harmonic motion. Now we'll do the same thing for velocity as well. So if you see, for velocity we'll have to see the velocity coordinate 0 comma a omega, t by 4 0, t by 2 minus a omega, 3t by 4 0, t a omega, and 5t by 4 goes to 0. So 0 starts with a omega. So 0 starts with a omega. Before that, I'll just club all the axis points. So the axis points are like t, this is t by 2, this is t by 4, this is 3t by 4, and this is 5t by 4, and this is 0. And the maximum value for, if you can see, the maximum value is a omega, and on the positive side, and the negative side it is minus a omega. So it would look something like this. This is a omega, so I'll write with a pen, this is a omega, this is minus a omega. Now the first point says it's 0 comma a omega, so it's 0 comma a omega, so time is 0, the point is maximum, so my graph would start from here. Then it would go to 0, I guess, t by 4. If you see t by 4, t by 4 is 0. So let's see, we can, t by 4 is 0, so t by 4 is 0. Now you can just extrapolate it. So maximum 0, negative maximum. Now this is the negative maximum, then goes to 0, then goes to the positive maximum, and then goes to 0. So if I join it, I would something get like this. This is the first line, and then you have this curve like this, and then you have this going up. So this is that curve. Okay, I just made an error over here. This is going to go like this. Okay, so you see the orange curve is velocity time graph. Now what we can do is we can also plot for acceleration as well, and if you note that 0 0 and then t by 4 minus omega, that means the graph for our acceleration starts from 0 and goes to the negative side. So I can just work on this, and I can just plot this graph like this. So it starts from 0. Oh, I made a mirror. This is maximum, this is 0, and this is t, this is t by 2, this is t by 4, this is 3t by 4, and this is 5t by 4. Now the maximum value for acceleration, if you can see, the maximum value for acceleration is a omega square on the positive side, and negative side it is minus a omega square. So your axis will go from a omega square to minus a omega square. So let's see how it works. So it starts from 0 comma 0. So if you can see this point, 0 0, when time is 0, the acceleration is 0. Then t by 4, it goes to minus a omega square. So it starts from 0 and goes to the negative side. So it starts from 0, so this is the first point, and then it goes to the negative side. So this goes to the negative side, then it will go to 0, then it will go to the positive maximum, then it goes to 0, then it goes to the negative maximum. So this is the way how it works. You see, it's a very easy kind of thing. And then I'll just join the graph. Okay, so just a minute. It would look something like this. Then it would work like this. Okay, just a minute. And then it works like this. So this is the displacement, velocity and acceleration graph. There is some conclusion as well. I'll be discussing this conclusion shortly in a next video. Thank you so much for watching. Have a nice day.